Let me share the screen. So this is related to the problem set 3, but I'd like to explain how to visualize the each qubit to the point of the Bloch sphere in the intuitive like the way. And it does not really mean that so after this explanation you figure out everything completely so that I will just skip every necessary explanation. It might be needed to repeat so that it will eventually click with your own intuition. So the concept of the qubit, one qubit especially. So this means an element of C2. So that's our starting point. You can kind of imagine, so how do we replace from the classical concept of bit to the like the qubit? So it's based on the quantum mechanics in a sense that rather than just changing from one to zero, so we kind of assume that those like the sit inside of the some very fancy quantum computing in the complex Hilbert space or whatsoever, so that we just change the zero and one as a complex numbers. So that's why we consider C2 rather than just a finite set. It's already like a fancy here. So what we'd like to do, especially, this is actually more special. So not only that, so it's satisfying. So its magnitude equals one. So this is the condition also all coming from quantum mechanics, and this allows us to get the probabilistic like the interpretation. But mathematical like the part, let's just take this as a sort of the axiom that we will not change it. So that i.e. So you can kind of, if I use the fancy notation, so this H stands for the complex Hilbert space. So we just take this to be C2. And in fact, this condition for me is tricky in a way that, so the quantum, like the computer plays a central role if one considers so-called the concept of the entanglement. And in order to look at the entanglement effect, one should look at the concept of the two qubits, not from just the one qubit. However, from two qubit, I don't think that can be done for the all the level of the undergraduate because there are lots of the necessary like the language to learn. Whereas for the one qubit, it's quite easy to visualize that we are now trying to learn, and also one can actually easily grasp our puzzle like the intuition. So this like the assumption for me is a little bit tricky. So that because of this assumption, I can make the project for undergraduate. But from like the two qubits case, it becomes like the C4 and like the C6 and so on. In that case, so one just need to learn further. Just that's it. So in that case, so we just look at the consider the following. So Z consists of Z1 and Z2 in this Hilbert space, such that we will make this norm equals one. And let me be clear. So for our own understanding, so let me just recall that if we have the z dot omega, z dot omega, so that this means that z consists of two tuple and omega also consists of two tuple. And we define this concept of dot product. I assume you saw this before, but you might not be familiar with the setting of the complex numbers. So real numbers case, you already are very familiar with it. So we will define this so-called Hermitian inner product. So the reason to put complex conjugate for the second component is we'd like to make, if we put same z and z, then you can easily now see that c1, c1 bar plus c2, c2 bar makes this to be always greater or equal to zero. So this is the way that we can define the concept of the magnitude square magnitude square. Is that make sense to you? Because this is, in order to talk about the magnitude, we don't want to get the complex value. We always want a non-negative real value in order to do it. Without the complex conjugate on the Hermitian inner product here, we cannot say it. So that, let me just be clear, i.e. the magnitude is defined as a square root of z dot z. That's the definition. So the collection of the one qubit precisely. So let me just give you the definition. So collection of one qubit is just nothing but the set in situ satisfying its norm equals one. That's the definition, mathematical definition. You can simply just say, so we start from the complex Hilbert space, and for the probabilistic, like the necessary interpretation of the quantum mechanics, so we just make the norm always or magnitude of the vector equals one. That's our like starting point. Is that okay with you up to here? All right. And from here, now I should make something fancy that you didn't see this from the homework problem set 3 because you didn't initiate this yet, but this is what eventually you need for the project, and this is our the goal to really do something fancy. So what we do is we define so-called the concept of the group action. The term is very abstract and fancy. However, in our setting, it is not that fancy. It is very concrete. So there are several like the steps to define this like the concept. And by the way, all those like the definitions are for defining the concept of Bloch sphere in a way that if you just look at the problem set one, so it's just nothing but the just a bunch of the metrics like the multiplications as you already have experienced. Whereas, so all of a sudden, we just change the perspective to the Bloch sphere in some way. So there's some conversion. So that we need to know why we can change all of a sudden from the complex Hilbert space to the some like the fancy like the geometry like the figure. So what the heck was going on there? So in order to understand it, we actually need to know this concept. So so first let me define. So one-dimensional sphere, or you can just assume this is just a circle. So circle just means indeed just nothing but e to the collection of e to the I theta. So theta, you can simply just take. Of course, you can just restrict to say just from 0 to 2 pi whatsoever, but doesn't matter. You understand what this is, right? Just a circle. Just a circle. And let me be clear. So even though this is very clear from the description, I just want to make sure that from the Euler formula of the calculus, like the class, so this can be written as, so this is usually called by the Euler formula. It's driven from the power series of the cosine and sine or whatsoever, but you can also accept this as a fact. I also assume you saw this maybe a long time ago. So that this like the expression is the complex valued. Are you okay with it? E to the I theta is not real. It's in general complex. And so I'd like to say it admits, I'm talking about S1, admits so-called group structure. I didn't mean that you should study the group theory of the abstract algebra whatsoever. You just need to understand what this means in this like a context. It means three things. So if you look at the multiplication, it is very clear. So we just take the complex like the multiplication. Then from the exponential law, this is clear. You get that? So we can say that, so this like the set is closed under the complex multiplication. So that we have a binary operation. And if we just choose two elements from the circle, then if you multiply, then still it should sit inside of the circle. And it is intuitive, very clear. We just kind of proceed the rotation. And so what you can also see is that if you multiply, it is very trivial. But if I choose theta equals 0, what is e to the 0? This is 1 for sure. So multiply by 1, just a trivial, it would be the same. So in that sense, we call this guy, or 1, the identity element. So we say this is the identity in a sense that this is the unique element that makes, if we multiply by any element, still we will not change that element. And that can be achieved by only this like the e to the I0. There's no other such like the element in the circle. So this is the identity. And I also assume you saw the at least naively the concept of like the group structure before, but I just want to make sure that we are on the same page. And lastly, so if we look at this guy, so this is so-called the concept of the inverse, so that we will get this one, so that this is the concept of the inverse element. Of course, this inverse element depends on the choice of the e to the I theta for sure. But for each e to the I theta, we can always find the inverse element that makes the multiplication equals the identity element. Of course, I actually kind of just say that. So associative law is the standard for the group operation so that you can change the like the order of the multiplication. So those are satisfied on the like the circle with the complex multiplication. Is that okay with you? So, so here, the reason that I need to explain this for you later on is that so we will consider this as a sort of the phase effect. So now let me try to explain. So from now on, you need to use your own imagination what happens. So from this page, I'd like to write something quite fancy. So please ask any questions if you feel something very fancy or if you feel it's not clear with you. So now let's just go back to here. So let's just go back to the definition of the one qubit. So I want you to kind of imagine this notation. I'd like to this notation eventually. So why we call this like why we denote this like the circle just a S1? Because this is a sort of the one-dimensional sphere. Do you get that? One-dimensional sphere. So in some sense, R2 is same as C1, and we just collect the unit vector. So I wanted to imagine clearly. So you start from either the complex plane or R2. Are you with me? And then just collect the unit sphere, unit vector, and that collection of unit vector becomes a circle. Is that okay with you? If you go to the one-dimensional higher over here, R3, if you collect the unit vectors, what do you get? Two-dimensional sphere. It's a surface, not inside. Not on the, we are not talking about the interior. I'm not talking about the ball inside. I'm just talking about this surface. Are you with me? If you just look at, so I'm just talking about, so if you have this space would be R3 and collect the unit vectors like this. This unit vector, collection of the unit vector becomes two-dimensional sphere. Does that make sense to you? I'm asking your like whether or not you click with your intuition. So if you start from R2, you will get circle. If you start from R3 and collect the unit vectors, then you will get two-dimensional sphere. Is that clear? Now, I assume you know what I'd like to ask. So you can see that this can be identified as R4. So we are going one dimension higher, and we still collect the unit vectors. Then what should be the correct notation here? S3. So now this is a three-dimensional sphere. So I want you to think this like the intuition step by step. You start from R2, unit vectors, circle. Start from one dimension higher, R3, unit vectors, two-dimensional sphere. Up to here, we can really visualize it. But from R4, you can kind of imagine what is R4, kind of okay, but we cannot really like the draw it rigorously. But still, we can collect the unit vectors. Are you with me? Unit vectors. Then we want to call it by the three-dimensional sphere. So that's why we denote this by S3. Is that okay with you up to here? S3. So now we can do is the following. So define the group action on S3. And I'd like to make sure that we have this as a subset inside of C2, but this is not, this is just proper subset. So let me use the fancy notation that we start from the C2 here, and we just collect the unit vectors so that see you can see that the ambient space is we start from either R4 or C2, but we'd like to use the complex like the number so that we just start from C2 and consider the subset as a S3. Is it okay with you up to here? So and we define the group action as follows. So let me say it like this. By S1, sit inside of C1 as follows. Then you should imagine what we wanna do. So you have like this guy, and let me just pick arbitrary element, say Z. Z consists of Z1 and Z2. Is it okay with you? And the common notation, I want you to also use the same notation when you present in front of others. So we will have another C1, and we use this type of the fancy notation. This is a standard notation in mathematics. So this notation represent we want to make the action on S3 by S1. So if you choose arbitrary element from here, this is e to the I theta. Is it okay with you? E to the I theta. And the common notation for the action is we simply just put the dot here. This is nothing to do with the dot product, but this is just common notation of the group action. Is it okay with you? So I want you to now define this object in a natural way. So now you can see that you have two complex values, z1 and z2, and we just pick one like the e to the I theta all of a sudden, then what can you do in the natural way? Do you have any suggestion? Please
Multiply to each.
multiply to each. Exactly. So let's just simply, because that's what we can do. So let's just multiply by e to the I theta on each component. Okay, let's consider this. So now I want you to understand some magic. So now let's see, observe. So I will eventually write down something here. But for a moment, let me just write down in the bottom line. So we know since Z is the element of S3, what does that mean? That means the magnitude equals 1. Is it clear? Definition. So because magnitude is 1, square still 1. And this is same as Z dot Z. This is same as Z1, Z1 bar plus Z2, Z2 bar. This equals 1 for sure. Now I want you to realize that if you look at this guy, let's just call it by Z1 prime. This guy is Z2 prime. Let's try to investigate the same, like the quantity, Z1 prime, Z1 prime bar plus Z2 prime, Z2 prime bar. Let's see what happens. Then Z1 prime just means e to the I theta Z1. Is it okay with you? This is Z1 prime. So when we put the complex conjugate, what happens? What's the
The
complex
I
conjugate? Yeah.
the imaginary part turns negative.
So we will get e to the negative I theta here first, and it becomes C1 bar. Are you with me? And those are our more complex multiplication. What happened? E to the I theta times e to the negative e to the negative I theta, they will be canceled. Because this is a complex multiplication. You agree? And we should repeat for second, like the component. So e to the I theta, Z2 times e to the negative I theta times Z2 bar. So that it will be also canceled. So that our thing left is Z1, Z1 bar plus Z2, Z2 bar, and we assume this equals 1. So this is like the astonishing in a way that, let me first say something trivial. So if this belongs C2, this is trivial. This is just a element of the C2, but what we actually get, this actually sit inside of S3 with any theta. Can you get that? This is our justification. So that what we have is this relation. So this is we call the group action. So today, all we actually need to get is the intuition about like this like a procedure. This is what I need to today explain. So let's try to imagine what really happens. So we start from the three-dimensional sphere. We cannot really rigorously imagine because we cannot visualize it, but kind of we know how to think of. So circle, one-dimensional object, two-dimensional like the sphere, and we should go one dimension higher. So that's the way to think. Is that okay with you? Then what you do here is yes, sort of okay. So what you do is you multiply by e to the I theta. What does that mean? So you fix the element point on the three-dimensional sphere, and then you kind of rotate. Can you kind of get that? You kind of rotate so that this is the effect of the so-called great circle in a way that if you move the theta parameter from 0 to 2 pi, what happened? On the three-dimensional sphere, so you start from the chosen point, then you really rotate along the circle, along the like a circle. Can you kind of imagine it? Is that okay with you? So still we can always just find the like the so-called great circle that rotate exactly one cycle on each of the point. If you have any questions, let me know.
Am I interpreting this wrong? So this gray circle you're talking about, it's the S1, the EI theta. That's a circle we're talking
Yeah.
about?
Yep. Yeah.
Okay.
Yeah. So the effect of the e to the I theta and the theta variable varies at least from 0 to 2 pi, right? Then you can, I wanted to get your own like the imagination that we start from the three-dimensional sphere and we really like the rotate this point and it will go back to the original target, like the given point. Is that kind of make sense to you? Yep. So now I welcome you to now understand the Bloch sphere. So now let me show you one like the picture. This is the all necessary concept that you should understand for proceeding the project. So what I explained is quite fancy, quite fancy. So please keep this like the name for your own like the study, not only for this like the project, but I want you to now appreciate this like the beautiful geometric like the figure. So if you look at such like the picture, so we have like the discuss about the three-dimensional sphere. Is that okay with you? Three-dimensional sphere. And then for each point, we can always find the circle inside. Then this can be done for each point. Is that kind of okay with you? Is this picture kind of make sense to you? So each of the point, we can always rotate one cycle. If you have any questions, let me know.
Wait, could I? So the interpretation I have is like if we have a point on a sphere, let's say like this, we're saying that there can be like a entire new dimension of like circles you could form with it.
Yep.
That's the S1. And then
Yeah,
S3 is
so
just the
that
point
like the
on
cycle is same as the
because like
S1.
because
Yep,
like there's different types of circles you could form on it. That's the
yep,
S1. And then S3 would just be a point on the sphere or on the sphere, I
yep,
guess.
yep,
Yeah,
yep, yep.
okay.
And those like the bunch of the circles becomes three-dimensional sphere. So it's kind of the fancy object to imagine, but it's kind of beautiful. Of course, still I need to explain why all of a sudden why you are talking about this one. But still, is this intuition make sense to you? Now you're really ready to understand the concept of one qubit. So far, I'm actually telling you a little bit like up to here. So, so if you assume the one qubit is the, so let me now go back to my night note. So now you might need to think about this a little bit heavy way. So here's a real definition. So what I said is rigorously okay, but that's not the actual way to think. So we start from S3. You know what S3 is, right? What we want to do is let me make the fancy notation first. We will take so-called the quotient by S1. This weird notation, we divide the set by another set is very weird notation. This means the following. So this is defined by the collection of the Z. Z sit inside of S3. So where this guy means this is a collection of e to the I theta. Theta is any real value. So this weird notation is, this is not the end of the description of this definition yet. I need to explain it fully further. But up to here, I want you to understand what this means. So this notation of the quotient set, S3 quotient out by S1, is the collection of the set. This is now quite abstract. So this like the notation of S3 quotient out by S1 is the collection of the set because this like the bracket of the Z is also another set. So the element itself is now the set. Is that okay with you? What does that mean? So we fix one representative of Z and we make the gray circle. And we want to just regard that as a one element. This intuition later on will be important for your project. So let me just repeat. So if you look at the picture of the hoop vibration, this guy, so your like the naive point of view is that so for each point on the three-dimensional sphere, so you can always rotate along the gray circle, but each point on the gray circle are different like the points on S3. That is not the point of view of the one qubit. What we assume is because of the like the effect of a level set of the quantum mechanics. So as long as they are living in the same orbit, we will view them as just the same element. That's our viewpoint. So now you need to really like to use your own brain to really imagine how it look like. So we are not looking at this like the picture, but we just view this each of the orbit as a one element. Can you get that? So let me just repeat for the sanity of the understanding. So we are not viewing each of the element as a different like the element, but as long as they can recover from one to the other by just rotating the gray circle, then we view as the same. Is that okay with you?
Are we basically saying each circle is its own element?
Each circle is the element. That's the
Yeah.
precise understanding. But this is not the end of the like the story yet. Can you imagine how it looked like? Now you have a collection of the circles. Can you imagine how it looked like?
Would it be just a sphere?
Yep, that's the answer. So this is called a Bloch sphere. So that's why you identify each element of the Bloch sphere, which is nothing but the two-dimensional sphere indeed. This is rigorously visualized in R3 as a one element of the qubit. But rigorously speaking, we are not talking about just a one element of inside of the C2, but we consider all the like the phase effect is identified as the same single element. That's the way of thinking. So it is a little bit like the fancy. Let me just repeat for you to understand the situation. So if you just look at the like the quantum mechanics, like the framework, then the one qubit is described as a unit vectors of the complex Hilbert space, that kind of thing. But if you really just look at that, then this is it's a different like the dimension. It is must be a three-dimensional object because there's a one like a equation, so that we should just decrease one dimensional like the less. However, we also identify the effect of the global phase. It becomes indeed a two-dimensional like the sphere. And this is we call the Bloch sphere. And in our like the project, we will call it by the complex projective line. Denoted by. So many textbooks use this notation, but I personally like this. It's up to you. You can use any notation for your presentation later on. By the way, I will share this note after our like the discussion. So because of that, I want you to now appreciate the perspective of the element of the Bloch sphere. So it looks like something like this. I assume you saw this when you try to complete your like the problem set. So this is the common notation of the cat that is now viewed as an element of C2, as you know, and we are already view this guy as a say 1, comma 0 in C2, and this guy is viewed as a 0, comma 1 as a, like a standard like the basis or whatsoever. So we usually identify one qubit in the following way. So this is a linear combination of those standard like the basis, but the expression is now look like cosine of theta over 2. I assume you saw this before, but it might now match with your intuition. So, and this part is a sine theta over 2. And then you need to just multiply by e to the I phi. And this is the expression correspond to the element of the Bloch sphere. So that you can now see that indeed we draw this S2 in R3. Does that make sense to you? This is really like the sphere in R3. So that this can be really rigorously like the visualized. And now there is an effect of the three like the different like the axis, X, Y, Z. And as you know, there are three different like the effects. One is the angle this way. Another one is the angle this way. So now what you should do is the following. So for all like the metrics, like the operations that you have done so far should be reinterpreted for like the doing some operation on this Bloch sphere. So for example, so if we go back to the problem set 2, let me try to open it. Now I want you to click with your own intuition at this point. Let me share that one first. So it looks extremely fancy. Although you know how to proceed, although it's like the metrics like the algebra for sure, that's elementary. But on one hand, it looks a little bit like the abstract and fancy enough. So here is now I want you to imagine. So of course this is just examples for that. So there is so-called the concept of the Z spider and X spider. So what should be the meaning of the Z spider? I'm not talking about the metrics like the algebra. I'm talking about the geometric interpretation on the Bloch sphere, what it should be. So this Z and X represent what?
Uh,
Rotations along
Rotations. Mm-hmm.
the circles on the sphere, like the theta and the phi.
Mm-hmm. Yeah. So Jason, do you have any other comments?
no, I was going to say like rotations also, basically.
Yeah, exactly. But I just wanna make sure you're like the establish your own intuition. Z spider means we fix Z axis, and accordingly we have an XY plane. We will rotate accordingly. What about the X spider? We fix X axis so that we have a YZ plane. Can you get that? And then just we rotate it accordingly. Then you can interpret everything. We rotate along the like the equator and so on. We start from the North Pole, South Pole, all those like the rotation can be interpreted on the Bloch sphere accordingly. Does that make sense to you? Now you can really like click. So how to geometrically match with your own intuition and the metrics like the algebra. Up to here. Is that okay with you? So, and then as you can now see, so there are two important like the concept. One is a Z spider and X spider, and the Hadamard gate is used to go from one to the other. Of course, this can be easily checked from the matrix multiplication for sure, but we are not talking about that. What's the meaning of the Hadamard like the gate?
It's a 90-degree rotation.
So
I
we
guess.
just change the axis. So we just change the reference like the axis from one to the other. So that's the meaning of this, like the putting like the H and H, like these two. So that just give us the way, metrics like the algorithmic way to change the axis from one to the other. Just that's it. So the desire is the following. So let me just finish the record up to here because for like sensitive part of the project, I don't want to make the record. But this is the general like the understanding of the concept of Bloch sphere, so that you should imagine something like this. So eventually, the collection of the one qubit just is represented as just a two-dimensional sphere that we usually call it by the Bloch sphere. Then you know how to just move one point from one point to the other. Then if you want to really just use the mathematical formula to proceed like the moving from one to the other accordingly, then we have the matrix algebra to do so. So we don't start from the matrix algebra, truth be told. We start from the Bloch sphere, and we have some desire to make some like modeling, depending on our like the context. Then, if we wanna make the precise algorithm, then we just convert everything in just the matrices. Just that's it. And now we just need to introduce some of the context to do something. Just that's it. Is that okay with you? So the problem set 3 is about understanding the concept of group action, and this is like the concept is one generalization. So yeah, for the record, if you have any questions or comments, let me know. Yeah, I think it's okay for us. Then let me stop the record.